Everything you know about the birth of the sun ignores a violent event that nearly destroyed the system before it even existed. We live in a universe where time, space, and galaxies seem to follow an eternal order, but the reality of matter and energy reveals a far more chaotic story. Gravity, that invisible force that holds stars in place, is the same force that shapes light and particles in a dance of creation and annihilation. What few realize about this point is that the expansion of the cosmos is not just a movement of objects moving away from each other, but the continuous fabrication of the very fabric of reality. If the universe is expanding, where is it going? Is it expanding into something larger, or is nothing literally creating something right now? This is the frontier of physics, where certainties begin to dissolve. Science functions as a powerful tool for historical reconstruction, allowing us to look back to the first seconds after the Big Bang, even if no one was there to witness the beginning of it all. The documentary evidence of this remote past is recorded in the cosmic microwave background radiation, an echo of light that has traveled for billions of years to tell us how the stage where we exist was set. Understanding this origin is fundamental, because the nature of space-time defines all the rules of the game we play today. Imagine you are in a theater where the stage not only houses the actors, but grows, stretches, and transforms as the play unfolds. That's the feeling of studying modern cosmology. We often visualize the universe as a bubble growing in a dark void, but this mental image betrays us. There is no outside. Expansion is an internal phenomenon, a change in the metric of what we call the void. As we explore the origins and evolution of the universe, we realize that every atom in your body was forged under conditions that defy common logic. We are delving into a mystery that connects the birth of the first particles with the ultimate fate of all galaxies. What we are about to discover seems impossible to our senses, accustomed to the macroscopic world, but mathematics and astronomical observation do not lie. Prepare to question the basis of your understanding of what emptiness is and how matter arose from what appeared to be the absolute absence of everything. What you're about to see seems impossible, but the physics of extremely high energies confirms that the beginning of everything was a succession of symmetry breaking at an astonishing speed. In the first moments, the temperature was so high that the forces of nature as we know them today were fused into a single superforce. Space expanded faster than light in a process called inflation, stretching microscopic quantum fluctuations until they became the seeds of galaxies. Light could not travel because the universe was a dense, opaque plasma. Hydrogen formed, helium emerged, gravity began to clump dust and gas together. The first stars were born and died in colossal explosions. Primordial black holes may have emerged in this chaos. Galaxies collided. Time began to dictate the pace of evolution. Dark energy took control of the expansion. All of this happened in a chronology that science can map with frightening precision. However, there is a disturbing detail that history often ignores. As we look at the large structures and the background radiation, a silent paradox remains hidden in the equations. Keep this detail in mind, because it breaks all the laws we will see later and calls into question whether we truly understand the relationship between gravity and the vacuum. We will call this the frontier enigma. If expansion creates space, what happens at points where gravity is so intense that space seems to tear apart? This question is at the heart of an intellectual conflict that separates the greatest geniuses of humanity. To understand the scale of what we are dealing with, we need to look at the numbers. Billions of light years of distance are not just measures of space, they are measures of time. Looking at the sky is looking at the past. But what if the past contains information that shouldn't be there? What if the structure of the universe is not as continuous as general relativity suggests? Mathematics proves that at extremely small levels, space-time can be frothy and unstable. With every millimeter we advance in technical understanding, the overall picture becomes more complex and intriguing. What you believe to be a solid foundation is, in fact, a dynamic field of particle interactions that we have barely begun to name. The density of data we have collected in recent years through space telescopes has radically changed our view of cosmic inflation. What was once pure theory now has solid observational evidence, but each answer brings with it a new layer of mystery. If the universe arose from a quantum fluctuation, what guarantees that it is stable? What prevents a new fluctuation from occurring and instantly changing the laws of physics? This type of questioning pushes us to the limit of what the human mind can process. We are talking about a system that self-organizes from primordial chaos, following patterns that repeat themselves from subatomic particles to superclusters of galaxies. This connection between the micro and the macro is the key to everything we will discuss. This would perfectly explain life and the structure of the cosmos if it weren't for a fact that science has found in the depths of space that says exactly the opposite about the stability of our reality. The intellectual victory we feel upon understanding the expansion of the cosmos is merely a temporary exit visa before we cross the border into a real conflict zone. To understand why gravity is the absolute protagonist of this story, we need to look at the fundamental thesis that underpins everything we see: general relativity. What few realize about this point is that gravity is not a force that pulls objects, but a curvature in the very fabric on which they rest. Imagine space as an elastic net, where each star and each planet sinks, creating trails that other objects are forced to follow. This solid logical basis allows us to predict the movement of galaxies and the orbits of planets with surgical precision. We live under the dominion of macroscopic laws that seem to follow an unshakable order, where mass dictates how space should curve and space dictates how mass should move. However, this harmony hides a question that has intrigued humanity for centuries. If the universe is infinite and full of light, why is the night sky dark? This enigma, known as Olbers's paradox, finds its answer precisely in the dynamic nature of the scenario we are describing. Since the universe is constantly expanding and light has a finite speed, the brightness of infinitely distant stars simply hasn't had time to reach us yet, or has been stretched by the expansion until it becomes invisible to our eyes. This reinforces the idea that we inhabit a system that follows predictable and functional rules. But this security is a necessary foundation for the shock that is to come. We are about to analyze how these same laws, which so well explain the brightness of the stars and the darkness of the night, begin to whisper about the existence of places where space-time itself can be crushed. The thesis of traditional cosmology gives us the comfort of understanding, but also prepares us for the moment when physics will cease to be merely a description of motion and will become a test of endurance for reality. What you are about to see seems impossible, but the mathematics that describes the evolution of stars reveals an inevitable fate for those with enough mass to bend the rules of nature. When a massive star runs out of fuel, the internal pressure that sustains it disappears and gravity takes complete control, initiating a collapse that nothing in the known universe can stop. Atoms are crushed, nuclei collapse, density increases to unimaginable levels. And most impressively, this exact process I have described is the reason you find gold in specific veins here on Earth. Without these extreme collapse events and the stellar explosions that accompany them, heavy elements like gold wouldn't even exist in our pockets, as they can only be forged in the most violent conditions of the cosmos. This is a reward pill that connects the jewelry you wear with the catastrophic end of a distant sun. As we delve deeper into the mechanics of this collapse, we realize that the curvature of space becomes so pronounced that time begins to pass differently for those observing from the outside. According to relativity, the stronger the gravity, the slower time flows. If you could observe a collapsing star, you would see the process slow down until it seemed to freeze forever. But for the star, time continues its relentless course towards a point of infinite density. At this stage, classical physics begins to show signs of fatigue. We are talking about an object that concentrates the mass of several suns into a space smaller than a city. Light attempting to escape this gravitational field is pulled back like a stone thrown upwards. The surrounding space becomes a perfect trap. With every millimeter the star shrinks, the barrier between what is possible and what is forbidden becomes thinner. The logic that governs the solar system and calm galaxies still applies here, but it is stretched to its breaking point. It is fascinating to note how the same gravity that keeps our feet on the ground is capable of crushing light itself if it has sufficient mass at its disposal. This technical exploration shows us that the theory of relativity is not just a theory about the heavens, but a manual on the limits of matter. However, even with all this detailed description of the collapse, we reach a point where suspending the technical conclusion becomes inevitable. This would perfectly explain everything and close the cycle of stellar evolution if it weren't for an absolute need for concrete proof that the theory demands, but which the object of study itself seems determined to hide. Everything we have built so far about the order of galaxies and the dance of matter is confronted by an object that defies the very existence of logic. While gravity shapes space and time predictably throughout almost the entire universe, there is a breaking point where light is trapped and particles cease to follow the laws we know. We are entering the domain of black holes, the greatest antithesis of all established cosmological knowledge. What few realize about this point is that a black hole is not just a dead star, but an open wound in the fabric of reality that questions the conservation of information and the nature of energy. If stars are the engines of creation of the cosmos, black holes are the ultimate question marks. Science, which felt comfortable explaining the expansion of the Big Bang, finds here an adversary that refuses to be measured. The basis of our new investigation rests on a fundamental contradiction. How can something exist if the laws of physics say that, at that point, mathematics results in infinity? This is the conflict between the very large and the very small. On one hand, we have the perfection of orbits and galactic expansion. On the other, a singularity that crushes any attempt at classical description. The question that now floats in the void is whether the universe possesses a censorship mechanism that prevents us from seeing what happens inside, or whether we are simply using the wrong tool to read the map. Looking at the event horizon, we realize that the boundary of physics is not a line in space, but a limitation of our current understanding of how gravitational force interacts with elementary particles. This scenario of intellectual crisis is what allows us to move forward. The thesis of order now faces the antithesis of absolute chaos and infinite density. Prepare to see the certainties of the previous cycle dismantled by an object that, by devouring everything around it, threatens to devour our most cherished theories as well. What you are about to see seems impossible, but the existence of supermassive black holes at the center of almost every galaxy suggests that chaos and order are closer than we imagined. These gravitational monsters possess a disturbing characteristic that shakes the foundations of physics, the information paradox. According to quantum mechanics, information about the state of a particle can never be destroyed. However, if that particle falls into a black hole and the black hole eventually evaporates through Hawking radiation, where does that information go? Is it erased from the universe? If so, our entire understanding of cause and effect collapses. This is where the antithesis reaches its peak of complexity. We are dealing with a region where the curvature is so extreme that time and space switch roles. Within the event horizon, the direction towards the center of the black hole is no longer a spatial coordinate, but an inevitable moment in the future. You cannot avoid the center any more than you can avoid tomorrow. This distortion of reality is a slap in the face of human intuition. To make things even stranger, there's a phenomenon called spaghettification. If you were to fall into a black hole, the difference in gravity between your head and your feet would be so vast that your body would be stretched like a thread of mass until it became a chain of individual atoms. But keep this detail in mind, because it hides a profound irony. While your body would be physically destroyed, your image to an external observer would appear to be frozen forever at the edge of the horizon, becoming increasingly red and faint until it disappears. We'll call this the horizon echo. This discrepancy between the experience of the faller and the view of the observer is at the heart of the crisis in modern physics. General relativity says one thing, quantum mechanics demands another, and the black hole simply ignores the conflict. With every millimeter we try to advance into this darkness, mathematics returns system errors. What was once an elegant description of the cosmos now becomes a cry for a new science. We are operating at a level of energy and density where quarks and leptons are subjected to forces that we cannot reproduce in any laboratory on Earth. The mass density in a singularity is something that defies the very definition of a material object. This would perfectly explain the nature of the end of time and space, if it weren't for a fact that theoretical physicists recently discovered, suggesting that a black hole may actually be a holographic projection of information stored on its surface. The reconciliation between the ordered cosmos and the abyss of black holes requires us to abandon the traditional view of reality to embrace a new architecture, quantum gravity. Until now, we have seen how the universe and time seem to function under rules distinct from those governing space and galaxies on a microscopic scale. Matter and energy, when compressed to the extreme, force gravity to interact with stars and light in a way that Einstein's physics can no longer describe on its own. The emergence of new particles and fields is what allows us to glimpse the conciliatory factor in this journey. What few realize about this point is that the solution to the paradoxes we discuss lies not in choosing a side, but in understanding that the fabric of space-time is, in fact, an emergent phenomenon of underlying quantum interactions. Science is now in a transitional phase where we seek the geometry that connects the brilliance of galaxies with the silence of singularities. This quest for synthesis is not merely a mathematical whim, but a necessity for understanding how the whole is sustained. Imagine the universe as a tapestry where the individual threads are quantum laws and the final design is general relativity. If we look only at the design, we miss the essence of the construction. If we look only at the threads, we don't see the image. The unification of these views is what we call the theory of everything. Documentary proof of this quest lies in the new string models and loop gravity, which attempt to discretize space, transforming what we thought was a continuous void into a finite network of information. Understanding this connection is fundamental because it resolves the crisis of understanding we previously established. The scenario of conflict begins to give way to a harmonious structure where the black hole ceases to be a mathematical error and becomes nature's supreme laboratory. By exploring this synthesis, we realize that reality is far more integrated than our senses suggest. We are crossing the bridge between chaos and order, discovering that the same rules that govern the heart of an atom are responsible for sustaining the expansion of the largest structures in the cosmos. What we are about to discover redefines the concept of existence, suggesting that the universe possesses a common language that we are still learning to read. What you are about to see seems impossible, but the key to uniting the micro and the macro may lie in a particle that has been a theoretical prediction for decades, the Higgs boson. This particle is the manifestation of a field that fills the entire universe, giving mass to fundamental particles through a symmetry, breaking that occurred shortly after the beginning of everything. Without this mechanism, matter would have no substance, stars would not form, and gravity would have nothing to act upon. The Higgs field is the invisible glue that allows the structure of the cosmos to exist as we know it. But a deeper technical exploration takes us even further, towards the most elementary building blocks, such as quarks and leptons. Particle physics suggests that, at extremely high energy levels, all the forces of nature merge into perfect symmetry. The black hole, in this context, becomes the point where this symmetry is tested to the limit. The synthesis we seek proposes that space-time is not the stage where particles dance, but rather the result of the organization of these same particles. Keep this detail in mind, because it completely changes our perception of depth. If space is emergent, then the singularity at the center of a black hole is not an end, but a phase transition of matter and geometry. We will call this the leap of unification. This perspective resolves the information paradox by suggesting that everything that falls into a black hole becomes encoded in quantum fluctuations on its surface, maintaining the integrity of the universe. With every millimeter we advance in this theory, we realize that mathematics begins to heal from the infinities that once haunted it. We are talking about a system where quantum gravity acts as the universal translator between Einstein and Bohr. To make things even more interesting, the density of information that particle accelerators offer us today corroborates the idea that the universe is a data processor on a cosmic scale. What once seemed to be an irreconcilable conflict between the thesis of order and the antithesis of chaos now reveals itself as two sides of the same coin. The scale of what we are dealing with surpasses our three-dimensional imagination. We are operating at a level where time may be merely a statistical illusion and space a web of entanglements. This connection is the missing piece to understanding why the universe is so finely tuned for the existence of complex structures. This would perfectly explain the origin of everything and the workings of the most extreme objects if it weren't for one last observational frontier that still challenges our most sensitive detectors in deep space. As we reach the culmination of this journey, we realize that the universe, time and space are not merely abstract concepts, but the framework of our own existence. The galaxies we observe, the matter that composes us, and the energy that drives vital processes are all under the dominion of a single physical reality that we attempt to decipher. Gravity, which began as a simple force of attraction and revealed itself as the curvature of space, found its cradle in the stars and its greatest challenge in black holes. Light and particles served as our messengers, bringing data from remote eras so that we could construct this map of human understanding. Looking back now, we see that the contradiction between the order of cosmology and the chaos of singularities was not a mistake, but an invitation. The conciliatory factor of quantum gravity and the Higgs field has shown us that the fragmentation of knowledge is only a step before unification. This panoramic view allows you to understand that every atom in your body carries the memory of cosmic inflation and the synthesis of elements in the heart of stars that no longer exist. The overall context we have established from the birth of the solar system to the frontier of extreme events now comes full circle. We are faced with the conclusion that the macro and the micro are reflections of the same fundamental law that we are still finishing writing. This is the promise of an absolute understanding that transcends mere technical observation and places us as active participants in the history of the cosmos. The journey of knowledge has brought us from the solid foundation of Einstein's laws to the limit of quantum uncertainty, and now we are ready to integrate these two truths into a single narrative about the origin and destiny of all that exists. The final connection between the main theme and the discoveries we made reveals a universe that is, in its essence, pure and organized information. When we look at symmetry breaking and how the Higgs field interacts with elementary particles, we see the exact mechanism that allowed primordial chaos to transform into the complex structure that allows life. This union between gravity and the quantum world ceases to be a mathematical problem and becomes the biography of matter. We now feel the weight of this discovery, as it speaks not only of distant stars, but of the millimeter precision that allows you to breathe while reading these words. A feeling of grandeur envelops us as we realize that we are the means by which the universe observes itself. All the violence of stellar collapses and all the strangeness of singularities were necessary steps for the current harmony to be established. However, the contradictions we explored, where time stops and density becomes infinite, serve as constant reminders that our perception is still limited. These boundaries are not walls, but horizons that challenge us to think beyond the three-dimensional. The last remaining gap in understanding is not a flaw in the system, but the silence that precedes the final revelation about what truly exists at the point where current physics falls silent. It is in this zone of silence, where light does not escape and mathematics dissolves, that the ultimate secret of creation resides. There is something there that we have not yet named, a final piece of the puzzle that connects the end of a black hole to the birth of a new space-time. This breath is necessary so that we can process the magnitude of what we are about to conclude. The final word that reconciles all apparent paradoxes is unity. There are not two physics, but only one reality that manifests itself in different ways according to scale. The resolution of all the mysteries we have presented lies in the understanding that the universe is an interconnected system, where emptiness is fertile and darkness is full of information. We have finally managed to close the loop opened at the beginning. The violent event that almost destroyed the system before it existed was, in fact, the refinement process necessary for our current stability. The entire journey, from cosmic inflation to quantum gravity, leads us to a single truth. We are made of stardust that learn to think about stars. This binding of content transforms the coldness of numbers into an account of our place in the cosmos. The quest to understand the breaking of symmetry is, ultimately, the quest for our own origin. The closure of this process brings us a profound intellectual peace, because now the mystery does not cause fear, but wonder. You now hold a panoramic view of a universe born in fire, grown in expansion, and sustained by a delicate balance of forces that today bear your name. This is the definitive closure of our dialectical construction. Science is not a destination, but an infinite road that brings us ever closer to the truth about our existence. By completing this cycle, you have not only learned about physics, you have reconnected with the 13.8 billion-year history that resulted in you. Knowledge is the light that shines on the frontier of physics, illuminating the path to humanity's future among the galaxies.